What's going on, everybody? Welcome to Software Sundays. I'm your host, KD, and in these series, we talk about some of the latest news inside of the tech industry, as well as discuss some of the questions that we got this week on how to improve as an engineer and as a professional. So, with that being said, welcome to the show, and invite any of your friends. But let's get started. So, first for this week, I wanted to talk about a report that just came out from Google. They recently released a Dora AI capabilities report where they were going through some of the key concepts and learnings that they've gotten while deploying AI into a number of enterprises over the year. Some of those key learnings really focused on the fact that AI is an enabler for what teams can already do. It doesn't create some type of magic wand that once you get it, everything is solved across your organization. It still relies on some things like having a data governance policy, having good team communication and clear communication, having a way to version and source control your source code. Like, some of these things have to be in place before you can actually see the full benefits of AI inside of your organization or in your products. A lot of teams are jumping into the AI wave and following the trend without focusing on those fundamentals. But once you do that and you add AI into the mix without having any clear foundation beneath you, then you're more likely to have a challenge as you start to scale your teams and your projects, because the things that you really need this platform to stand on are not in place. One of the most interesting things for me was having a data governance policy in place. It's interesting because enterprises are some of the most valuable repositories for data. Every business transaction your company is processing, whether you're a financial services company, where actually handling payments, or you're a retail company where you're gathering different data points about your customer or user, those records that you are collecting, whether it's PII or just attributes based on the type of customers you have and their demographic information, that type of data needs to be stored securely. So governance does have a security aspect, but it's also having an organization aspect and a management aspect. If you're going to be storing terabytes of data over time that you want to get some type of knowledge and information from, you have to have a way to track how it's changed over time. What transformations has it gone through before we started using that final golden state data? If you're not thinking about what that data journey is going to look like before you start collecting the data, one, you might put yourself in danger of not meeting some of your regulatory requirements. But two, you might run into the problem where you're having garbage in and garbage out, especially when you start to exacerbate that situation by using AI. So having a data government policy that is in place will help save you and your customers some challenges. It really emphasizes to me how easy it is to start using AI and start adding it to some of your current operations. But if the operation is not in place, if the team doesn't have a way that they know how to move forward with the tool, the tool is not going to magically fix all of the problems that exist. You still need effective operators that can handle all of the nuances that will exist within your operation. So keep that in mind as you're building with AI and when you're looking to maybe open up some of your projects in 2026 to start exploring new use cases or, adding more users to those products. Another story I found highlighted the benefits of AI inside of the climate and energy space. I know a lot of commentary about AI focuses on the fact that it is a power-hungry machine. Because especially data centers that are driving the AI revolution, those are requiring immense amounts of power 24/7. First to train the models, and then also when providing inference for those models. These data centers are usually pulling energy and significant amounts of it from already existing infrastructure and power grids that may or may not have the excess capacity to support these additional items. And we're already having challenges with transitioning our energy infrastructure to actually start bringing more renewable energy sources online. So we're at the same time we're not transitioning to clean energy, we're having to use way more energy to support AI. And so there are some real concerns with AI and what its effects will have on the climate going forward in regards to energy. But one of the, something to keep in mind when you're thinking about what AI can do in the future, it will help solve some of the problems that we have for why we cannot move faster inside of our build-outs. Billions of dollars have been put into the system to help build the AI infrastructure that includes data centers, but also helping to refresh the energy grids that those data centers are being connected to. I know we did pause a few of the wind energy transitions and those build outs, but there are some significant research advancements being done for nuclear energy, which is cleaner and more reliable than solar and wind put together. So maybe the fact that we have this sudden and very large increase in demand might actually help us move faster towards a cleaner energy over time. So that's one potential scenario. Another thing that is going to be helpful as we continue to improve AI is that the models themselves will become more efficient. Right now we have reasoning models that are running subsequent, and they're running subsequent inferences on initial prompts, and sometimes we're running a bunch of those calculations back to back to back in a loop before actually responding with some type of answer. That is a very new use case for AI. And so as we move throughout time, we will start to see those reasoning models becoming more efficient, with how they're starting new requests, as well as with maybe parallelizing the inferencing. So you're not doing all of the tasks sequentially. You're having some of those things happen all at the same time, which would use less energy because you're doing things more efficiently with your time. So that may be one way we can make these models better and more efficient. Another thing that is happening is a lot of the earliest models were trained on vast amounts of data with no distinction between what a good data set was versus a poor data set. Now that we've kind of got to the limits of what just any type of data is going to do to improve these models, it becomes more effective to not try to store as much data and be more selective with the sets that you're pulling, which means you're going to be storing less data in these new models than you have in the previous models. It also means that the models themselves become more easily trained, but also smaller to run because they're using less data. And so that, again, is going to make it more efficient for us as we're thinking about AI and what that looks like over time. And another thing that we're going to see over time, and you can already see what's happening. I think Microsoft invested into at least one nuclear project. Google has, or maybe Amazon has also. But when the AI platform and the technology itself becomes a commodity, where the value of those things, even though they're going up, the price that you can charge for it begins to decrease. So the businesses that are supplying these models, and we're thinking hyperscalers, cloud companies, right? They're going to need to find another way to be competitive inside of the market. And so if the price of the model itself is not going to be competitive, you may get very small margins, but large scales, then they'll say, hey, maybe we can get a lower cost at the energy level. And so they're going to start looking for more efficient and cost-effective ways to either run the model or to get the energy for the model. And we do have some regulations in place where you can't just start burning coal, even though that might be the cheapest way to get energy. But at some point, we're going to start seeing the competitive landscape actually start to bring down some of the costs associated to AI and its development over time. So that's something, another beneficial thing in a way that capitalism is on our side. Another interesting story that I saw was that Nvidia actually purchased their main competitor, or one of their main competitors. Nvidia is now licensing Grok, G-R-O-Q, AI technology, as demand for cutting edge chips is growing. So Grok also creates chips for the AI revolution, but their chips are more focused on inference. And so they have engineered and designed their chips to keep more memory on the same wafer, which reduces the cost for running models on those chips. One thing, right? The fact that again, going back to these chips and the providers of AI are having to find ways to be more efficient. And this is just one other example of that. Maybe we can become more efficient inside of the actual physical hardware that we're using. Another thing is Nvidia, like other companies like Meta when they invested billions into scale, or Alphabet when they agreed to hire top executives from Character AI. We're seeing a large acquihire movement. We're seeing large enterprises, instead of just purchasing the technology that these smaller upstarts are developing, they're licensing the technology. And this might have been a common thing, and I just may not have been aware of it, but it's a different way of getting the results that you want without having to bring that skill and that talent in-house. Each side remains flexible enough that they can operate independently, while also making sure that a symbiotic relationship is formed where both sides can benefit. So it's very interesting to me that these types of partnerships are becoming more common, or at least more mainstream, with different technology partners doing it. The deal with Grok and Nvidia is non-exclusive. So Grok still has the ability to license that same technology to other companies in the space, but they're also being pulled deeper into the Nvidia ecosystem, where they can actually start to share their knowledge and what they're learning as they're building more easily with the people inside of Nvidia's team. And it's an interesting way that the market is moving, and I'm very much excited to look into other ways that other companies can recreate this trend. Because maybe you don't need to be acquired completely. Maybe you need to have a licensing deal where you're making your technology available to the companies that would be your major customers, or even competitors, depending on how you want to go into that. But you make your technology available and you build partnerships with them in a way that you can still keep your competitive advantage. You're not just selling outright, but you have a relationship that you can build on in the future. So it's like a win-win for both sides without fully selling out. And so with that being said, let's get into some of the questions that we have for this week. And let's think about how we can be better developers, entrepreneurs, and improve our success probability. Because everyone can be successful. You just need to have the resources and understand that you have the resources to be as successful as you need to be and as you choose to be. So let's get into it.
How can I combat scope creep?
So scope creep is a natural effect of excitement during a software project, and potentially any project. When you start going through the design, you start to see like, oh, these are the things that I can do. As the engineer on the project or the project leader, your job is to make sure that that excitement doesn't start to pull focus away from what we are actually here to build. As a leader on the team, you understand that your goal is to reach some type of milestone. That milestone can be an MVP, or it could be a V1 version or whatever you are actually shooting for, you have to make sure that that focus is always kept tightly in mind and it's not muddied by all the other things that we could do. It's important to keep an eye on those changes to the scope, because every time you add something to what is possible and you try to pack it into your current timeline or your current backlog or the current release, you're either going to put extra pressure on your team to build that within the same predefined timeline, or you're going to run the risk of expanding the time it would have taken to release that version, because now we have to add something in that is going to take, frankly, more time, more energy. So you have to be incredibly careful about what you allow into the scope as you go forward. And that's not to say that you ignore every change that comes in, right? Every time a client says, hey, we want this now, or maybe can we add this? It's not saying you say no to everything, but you have to be very selective about what you say no, what you say yes to. And if you're saying yes to something, you are saying no to something else. There are going to be trade-offs. As long as the client is aware of the trade-offs that they are making when they mention something new into the project, as long as that's clear and everyone is on the same page, fine. But usually it's not clear. Usually an ask will go to someone who does not have the authority to change the scope. And so they're changing the scope as an engineer, but the person who is responsible for the outcome and the timeline has not even heard of this new feature request. And so a tip that you can use to keep in mind when combating scope creep is to have some predefined process for taking in, analyzing, and approving or disapproving new requests. You want to make sure that there is one party who is responsible for taking those requests, or at least feeding those requests to them, and that they have a clear guideline on what can be added at what times or stages in the project can they be added. Maybe early in the process is fine, but when we're 2 weeks away from launch, not at all. We're not changing anything at this point. So having that guideline and those guardrails in place will be helpful for you if you're leading the project. But at the end of the day, you have to pick your battles. It's important for you to know that a change in scope, if it's just a simple change to a button, or the placement of the button, or it's the change of some very specific content that's in the page, that may be a simple fix that we can do as part of some other task. But if there are substantial changes being made to the flow of the data that we're using, or the dependencies that we're saying we need, that's going to require more energy and more effort. So if that's fine, if you have the capacity in your team and in your timeline to do that, do it. If you know you're not going to have it, you need to be clear about that as soon as it is raised, because you can always add something new to the backlog that we can handle when time allows. But anything you're agreeing to moving forward that needs to be in place, you gotta,
How does generative AI differ from legacy artificial intelligence systems.
So that's really interesting because I remember taking machine learning classes inside of university. And back then, I say back then, it was less than 5 years ago. But at the time, artificial intelligence, machine learning, it focused on predicting a classification. So it's statistical. It was how do we learn to predict patterns based on the data that we have available. And that could be how do I learn how to distinguish one type of customer from another type of customer. How do I learn how to measure the current price or value of a property based on the properties and values of other things in that area. So it was very prediction based, and it focused on just generating a single answer, either a yes or no, or a integer value, or even a probability. If you're saying yes or no, but how certain are we of this yes or no? Sometimes it was if it's greater than 70%, we're gonna say yes automatically. Sometimes if it's anything below that, we say no or maybe. So it was more prediction based for classifying a result. Generative AI took that predictive capability a step further, because now instead of just predicting the outcome, it's going to predict an outcome at it and then do another prediction to generate what's next. And so that's all Gen AI is doing, whether it's for text predictions or it's for image predictions or even videos or sound. It's just predicting what should come next. Based on all of the data that I have been trained on, I being the machine, the technology, can make a very strong guess that this is the next word or sound in this string. When you think about it like that, it doesn't seem like there's a large difference, but it opens the door to use cases that you could not do with legacy or classical machine learning and AI. Now, instead of just saying, I can predict whether or not this customer is my target customer, or you could say yes or no based on some type of data set. That's what social media has been doing for years. They can say, all right, this person may or may not be, or they may or may not find this video useful based on the profile that we have of them. And we have a profile of all the other people that watched this particular video or read this particular post. We can make a very strong guess whether or not this person will like it. Now, you can go a step farther. Instead of just saying whether or not they would like it, I can actually predict and create or generate a post that I know they will engage with based on what I know about them and the people who have engaged with similar videos. It makes that iteration process faster for the people that are creating these new capabilities. Even with a dynamic pricing technology, I can, with machine learning, classical machine learning, you could determine the value of something today and right now. But when you add the Gen AI functionality into it, you can create something new and give it a value. that it never would have had before, but you can be certain of how valuable it is because it's been trained and it's been taught that this is going to be valuable for this type of user. Machine learning, and so when I say machine learning, I'm meaning classic AI. Artificial or Gen AI is the more modern term and more modern technology that you hear about today. Machine learning had its use cases for certain problems. And then it also failed in certain problems where if you gave a machine learning model a totally new data set that it had not had any experience with, it would do really badly with predicting what was next for that particular user. Because it had nothing to kind of compare this outcome with or this scenario with versus the previous things that were happening. It's previous training data. So it would fail when the data looked new. Gen AI is a little different because you don't even have to train it on the data that you're giving it for it to make a fairly good answer. It can more easily use new data to make accurate predictions. And that's something that, again, we haven't seen that before, and it opens the doors to just more use cases for us.
What's the difference between unit testing and interrogation testing?
So the key difference is the range of systems being tested. If you think about unit testing, you're testing a particular item, an individual component inside of some system potentially, or it could just be an individual component that operates independently. You're testing that versus an integration test. You are testing a system and making sure that this system, when called, operates as you would expect it to operate. And that usually involves more variables because you have different systems that all have to give the right answer. And so if something is wrong at the input or output, it's more difficult to tell which individual component caused that problem. So that's why we jump into unit testing when we are seeing some issues inside of our integration test results. Depending on the size of the project is whether or not you'll call your test an integration test or a unit test. Because I could unit test a particular function inside of my API where I could test that at the service layer if I get a particular set of data that it gives me this specific output. And that is a unit test for the service layer inside of my API. But if I wanted to test that my API is working, then I could test from the request to letting it completely finish that the response that I got from that API was accurate. And that is an integration test. But that first test of the repository layer or the service layer or the handler layer individually is a unit test. But I could have a distributed system that has multiple different APIs that are all pulling and pushing data to each other. Now, if I test a specific API inside of that distributed system, then that is again a unit test. But it's for a much larger system or a much larger surface area that we're testing for. So it's almost a debugging strategy or a testing strategy to understand how fine grained do I want my results or my test or my experiment to be. Because you have to think about testing as an experiment. You have a hypothesis, you have an idea of what you want to happen. Now you just have to see if your hypothesis was true. Sometimes the hypothesis was true or it was false. And it could be that the system under test was wrong, or it could be that your assumptions were wrong. But you have to treat it like a test. So you have to have that hypothesis. You have to document clearly your inputs and your outputs and the number of experiments that you're running with those different input and output variables. Then you have to analyze those results and say, is this okay or is this not okay? That's up to you as the scientist, as the engineer, to make sure that the results are clear to you and that you can make them clear to anyone else who is interested in learning about them.
Which branching strategy do you think I should use?
So when you're determining a branching strategy for your team or your project, you want to make sure that it aligns with the team size, the project complexity, and your release goals. The branching strategy you choose should not be a hindrance to your organization's speed. You want to make sure you're getting changes out the door as quickly as you need, depending on how your organization is set up. If you're an enterprise, you may have slower paces of change versus a startup that is still actively building out the MVP or the finding product market fit. You may want to have a faster feedback loop. So you want to get things out to production faster. But that branching strategy needs to align with whatever that goal is for your team. There are different types of branching strategies. You could have trunk-based development where your team is just creating PRs off of one single branch, whether it's main or master, and you're releasing that main branch to production every day, and that is your releasable branch. That has its pros where things move much faster, right? Much tighter feedback loops. But unfortunately, you might have the challenge of when there's too many chefs in the kitchen, there are breaks that might slip through. So if you're going to have a trunk-based development style, you have to make sure that the CI/CD pipelines are top line. You have to make sure that your testing, there's automated one, but that those tests are actually going to find any of the bugs that exist in your system. And so it requires you to have more substantial infrastructure around your DevOps pipelines to make that work over time. But you could also have a branching strategy for Git flow, where it's a more structured branching strategy that has a develop branch and then a prod branch, and then feature branches are built off of develop and merged to develop, and then develop is merged to production or whatever that main branch is, and that main branch is what gets released to production. So you can keep develop, which is your place where you're just putting things together and making sure there's no merge conflicts. But you don't have to release all of those changes that actually are inside of develop. So that type of strategy is useful for a bit larger teams if you want to kind of separate the integration of code changes from the release of those changes, because you have that separation of the branches themselves. That, again, it requires some experience from your team to understand and remain disciplined that changes are only going to develop. You could automate some of those guardrails, but it really requires your team to just be aware of that in the strategy. And there are a few other strategies that you could choose, and you would probably end up with some combination of all of them. You could have a trunk-based development strategy to your develop branch, but then your develop branch is just the first stage of your Git flow or some other branching strategy where you have develop, which is for the dev environment, but then you have a staging branch and a production branch that really separates your releases into actual physical environments that you're being released to. And so, again, that requires some experience from your team, some discipline, some processes in place in your pipeline, and it's probably more suited to an enterprise environment or inside of a regulated industry, because you have to have some type of clear process in place to know what code is actually running in production and when it was released and how it was tested. But you really have to make sure that branching strategy aligns with what your team can actually do and what you are, seeking to do over time. So we did have another question that was not verbal, but what's the difference between the application and infrastructure layer? The difference is logical, as with anything. It's a mental model that you can choose to use inside of your project. If you think about your application as the business logic, as the portion of the system that is responsible for serving the request and taking some input and giving an output. Think about the application layer as the main driver of the business. And it has all of the workflows and capabilities that the business needs it to use. The infrastructure layer is more of a supplementary tool. You have the infrastructure layer in place to make sure that you have the resources like a file system, like a database, like a network that are available for that application to use and do all of its work. Think about the application layer as answering the question, what do we do? And the infrastructure layer is going to answer, how do we do it? So you should be able to mix and match your infrastructure and not have to change much inside of your application in terms of how data is flowing through your system. You should be able to have your application run on any type of infrastructure, because the infrastructure is not the application logic. And that's sometimes easier said than done. You have to know what layer counts as the infrastructure. Some people may say that a container is part of the infrastructure, but personally, I would say that your container that your application lives in is the application, because you can take that container and run it inside of a pure VM. You could run that container inside of a Kubernetes pod, or you can run that container inside of a serverless function like Lambda. Like, you can take that container anywhere and it'll run the same way, because it's an application that is infrastructure agnostic. Your infrastructure, on the other hand, is going to be something that you can either use for one application, or you should be able to use it for multiple applications. Let's say you have a product database that is used by the internal teams to manage inventory, but it's also used by the customer facing applications to render on the e-commerce website. You have the same database serving data to two separate applications, and that's something that you can't do if the contract between the application and the infrastructure is too tightly coupled. So you want to have that space, and you can have that space with a number of ways. You can think about the logic or the infrastructure as something that's plug and play for the application, and you can have different versions of that where you can make sure your application runs on a SQL database, but it can also run on a NoSQL database, or it can even run from a CSV record list if need be. But thinking about the application and the infrastructure as separate components helps you to make systems that are more reliable and maintainable over time, especially when you want to experiment with different technologies. So that's pretty much what we had for this week. Again, thank you everyone for listening, watching. If you enjoyed the series, please like, share, subscribe, comment, all that stuff. Let me know what your thoughts are. Let me know if there is a question that you have about anything that I mentioned today. And, let's continue to share the insights that we're getting as we grow inside of our career. Because, each one teach one, and, we got to build and learn together. But some final thoughts that I had also was that you cannot claim to learn a lesson if you continue to have the same activities or do the same activities, right? When they say insanity is just the process of doing the same thing and expecting a different result. Insanity is another version of you've learned nothing from the situation. If you're still pulling the same stunts, if you're still making the same mistakes and expecting something differently to happen, not only might you be insane, but you have clearly not learned the lesson that you were supposed to learn. Every time you have to learn that lesson again, it's going to be as painful, if not more painful, than it was the previous time. And it's going to feel even worse because you know that it wasn't supposed to be like that. You know what you could have and should have done. So that message is really just to anyone who is, I guess, on a ledge about whether or not they need to change something in their life and is wondering, do I keep doing what I've been doing, or do I switch it up here? If you do not like the outcomes that you are getting today, then it's healthy. It makes sense. It shows the growth and development. If you switch it up, if you actually take that lesson that you received and do something differently with it. In terms of community, how often do you want to be around people that are clearly not learning their lessons? They are making the same mistakes over and over again, even when the lesson is clear to you and even to them. So it makes, when you're not acknowledging that lesson, and when you're not actively changing what you're doing and the behavior that lesson should be relevant to, when you're not changing it, it just makes you a much less desirable partner in whatever it is that you may be interested in doing. So make sure when you're learning, you are implementing that learning into your lifestyle, into your thinking, into your activities, and actually internalize what you learn if it's good for you to know. And some shout outs. Happy belated birthday to my god sis Maddie. Her birthday was on Christmas, and so I hope you enjoyed all of the gifts that you received and you enjoy your day, life, and just everything is amazing for you. Because we love you and all that. And for this week, I know we got New Year's coming up soon. Everyone, have fun, enjoy the time with the family, drink responsibly, and just make sure we go into the new year safely and with level heads and level minds. We don't want no disruption of the peace. Let's get to the next year and let's do it better and all that. So see y'all next year. Peace out.